So now we're back with model 1. And in the instructions, model 1 says that it is only a model between the direct effect of the dependent and the independent variable. So let's try in here to kind of write the equation of the regression model to make it so we can understand what's going on. So which is the dependent variable? The dependent variable is happiness. That's what we want to explain. We want to explain if happiness is explained by changes in motivation. So if you remember also our lecture, the lecture in second lecture, we will have the constant in here, constant, plus the beta, which is the coefficient that we will calculate in SPSS of motivation. And then the error, just like this. This is kind of the equation of model 1. So keep this in mind and let's change to SPSS. So in SPSS, we need to go to analyze, regression, and linear regression, like this. And here we need to fill the data using the same model that we had in the equation, happiness, motivation. So the dependent variable is happiness. And the independent variable in this model is only motivation. So as simple as this. But before you click OK, you need to fix something. Go to statistics and click on collinearity diagnostic. And then click OK. And then we have all of these things, right? This maybe you remember from the quantitative lecture, we had all of this. So we have, you remember how do we start analyzing the regression model? If I go to the Word file, I will say that the first thing we need to check is the model fit. If you take a look at the PowerPoint presentation, the model fit is the first thing that you need to discuss, and you find it here. And if you remember, we want it to be less than 0.1. So good news, we model fit, it's okay. This is just big headache with now it, but you do it how you think it's better. Model fit, the significance is 0.03, so it's fine. My suggestion is that you copy the table. I don't know what's going on with my Word, but you copy the table. The next thing that you need to check is the multicollinearity. And to check multicollinearity, if you remember, is the BIF statistic. In here we have one. We cannot have multicollinearity problem because in our regression, we only have one independent variable. We don't even have controls. So it's impossible that there is multicollinearity because there is nothing to have multicollinearity with. So in this case, that multicollinearity is even not that necessarily multicollinearity. It's not a problem because you only have one variable, but you can report if you want. After multicollinearity, the next thing is the R-square. And the R-square in this case is 0.07. It's very low. But remember what I told you. In social sciences, it's okay to have low R-square and even lower because we don't have control variables. So we will assume this. And still is higher than 1%, which 1% is very bad, but we can move on, okay? So just report and don't worry. But finally, the coefficient, we want to test if this coefficient is positive. That's one thing we need to check because we assume positive relationship. So we want to check if the coefficient is positive, and we want to check if the coefficient is significant because we said that there is a relationship. Okay, so we need to test for these two things. So we need to check the significance and the sign of the of the standardized bet here. So the sign and the significance. So in this case, it is significant and is also positive. So that's very good news. So the coefficient is significant. And remember, it is significant at 99% because it is 1 minus 0.003, so it's 99.7%. So you can say that it is significant at 99% of confidence, and the sign is positive. So in model 1, we support the hypothesis, right? That's the conclusion, because this works, this works, this works, and the coefficient is significant and positive, as you stated in your hypothesis. So you are done with model 1. Let's do model 2 and model 3 in here. So we will expect to have the same output. Remember, copy everything. I'm not copying it because the problem I have with Word, but you do copy. And for this next question, model 2, we need to add the controls. That's what it is asking. It is asking in this model include control variables. So to do that, let's do analyze. I will go to linear regression. And now let's add all of this, the 6 controls, right? And then we click OK. And then we do the same tests that we had before. So first thing is the model fit. It's not a problem. So we have 0.012. Multicollinearity is not a problem because the highest BIF is this one, 1.325. It's not a problem because the highest BIF is 1.325. Remember that it is a problem if something is more than 4. If you have more than 4, then you need to take out that variable until it's fixed. It's a bit similar to the Cronbach alpha. The R-square of this model is, it's a bit better, 0.152. 0.152. Why do you think it's better in this model? The answer is because we have control variables. So this is a more robust model that explains better the variance of happiness. So this model is a bit better than the other one in terms of R-square. And then the very important, we passed all the tests. We need to check what happens with the coefficient. The coefficient of motivation is very low. So less than 0.001, that's good. We want it to be less than 0.1. And the coefficient is positive. So similar, it's exactly the same. The coefficient is significant at 99%, and the sign is positive. So the same conclusion, and we also support the hypothesis because we expected this. We expect it to be positive and to be significant, so we are fine. Let's do the last model. So the last model, I will just copy this. This last model will, well, I can fix that later. We'll have the controls, but now balance will also be a control. We will use balance as control. So we will have controls, balance, and error. So let's go here to SPSS, and then let's do the linear regression, but let's add balance as if it is a control, and then you click OK. So first thing to check, good. The model fit is fine. So let's report that model significance 0.001. Multicollinearity, we don't have multicollinearity. Remember, we were a bit worried, but no, there is no. 376, 1.376. So nothing more than 4, that's good. R-square, the R-square improved more. Why do you think it improved? It improved because we now have more variables. Our model is more robust. And the coefficient, let's check the coefficient. Coefficient for motivation, it is 0.005, so it's still 99%. And the standardized beta, the unstandardized both are positive. So the coefficient is positive. So the same is 99% confidence and the positive sign. So we support the hypothesis of model 2 in model 3. So because all of the models, in all the models, we managed to support in everything. It's a quite good example because we support in everything. The overall conclusion is that we fully support the hypothesis because, and then you explain in model 1, everything is with significant and positive at 99%, significant and positive. We tested for, so it's just a paragraph kind of summarizing everything. We didn't have any problem with the model fit. We didn't have multicollinearity problem. The R-square was significantly improving with more variables. So the conclusion is full support. Remember also that from our lecture that we had a quantitative step. So besides this, don't forget to add all the tables to this report. Then fill that report and upload it. That's the quantitative lab work. The quantitative assignment will be very similar to this with another database. I think that quantitative assignment is even easier. This is harder than the quantitative assignment. So do it. I hope it's helpful. You have the video, so then you can come back later, but we are done in here. Just, I hope you don't have the same problem I have with the with all this craziness of the figures. I hope you get it better, but that's basically all for this. So thank you and see you later.